Hello, today we are going to talk about how to create multiple logical routers inside a physical router using a Juniper MX router. Sometimes you may require a situation where you want to test a particular topology or scenario and you wanted to just quickly do it without having to connect multiple physical routers using physical cables. There is an option to achieve that without having to physically connect multiple routers or using physical cables by using a feature in Juniper called as logical router concept. Now what it does is, as you can see on the diagram, if I have a physical router, I can create multiple logical routers within that physical router, and I can have a set of configs that are only specific to that individual logical router. For example, here I have R1 which is created as a logical router, R2 which is again created as a logical router. So I can have specific configurations for each of these routers, and then I can have them interconnected using a logical tunnel interface that is configurable on Juniper. So what this really does is you just define the logical tunnel interface. You don't need a specific hardware to create this logical tunnel interface. You just have to enable it. I will share the configs. Once you enable it, all you need to do is just map which logical interface unit is going to talk to the adjacent box. As you can see here, I have defined dot 1 as a unit and dot 2 as the other unit. So we just have to map unit 1 is going to talk to unit 2. Likewise, unit 2 talks to unit 1. That is the mapping that's required. Apart from that, it is just the basic configurations that you would require. In this example, I'm going to demonstrate how I've configured logical routers, and I've also enabled ospf protocol. So let me quickly go to the configurations. As I was referencing, so this is an MX platform. You can use any MX to achieve this. In this case, I'm using an MX304. Now, the first thing that is required is under chassis, you have to enable something called as tunnel services. Now, when you enable this under set chassis FPC pick 0, because usually each line card has multiple FPCs. In this case, you can see this particular chassis has FPC 0 with pick 0. There's only one pick here. So I'm making sure that I pick that FPC which I want, and within that FPC I pick the ASIC or the pick within that FPC which is pick 0, and I just enable tunnel services with a bandwidth of 10 gig. In this case, I'm just only going to use tunnel services with bandwidth of 10 gig because I don't need to test with higher bandwidth or throughput, as I'm mainly focusing on validating my control plane functions or checking some features. Of course, if you want, you can increase this bandwidth to a higher value. It is possible. So let me show you that. Set chassis FPC 0. You select the pick, you select tunnel services, and you can see there's an option called bandwidth, and within the bandwidth you can have all these available bandwidth that you can configure. One key part to notice is this is a bandwidth that is allocated from the physical ASIC capacity. So if the ASIC that is a part of the pick 0 is like 400 gig, and if you are allocating 100 gig for this particular tunnel services, those bandwidth is available for tunnel services on demand. It is not like once you configure this bandwidth is never available for the pick as a whole. It is available, but however, when there is a demand for tunnel services, it is going to take that bandwidth. Now, how do we configure logical routers? As we explained on the topology, within the physical router, the configuration is quite simple to create logical routers. So first I'll show you what I've set up in my lab here. So the configuration is like under logical systems, you define the name of your logical router. You call the interface that is a part of the tunnel services. As you know, we've created tunnel services on FPC 0 pick 0. So the tunnel service interface is called as LT000. Now inside logical system R1, I call the LT interface. I define a unit 0, and I enable encapsulation VLAN, as it is easy to create VLAN encapsulation, and I define a VLAN ID. As you can see here, the most important part is the physical stitching. So for this interface LT000 unit 0, I have made sure that the peer unit is 1. So according to the diagram, you can see that 000 dot, sorry, this one has to be 0 and this one has to be 1. So the physical unit LT000 dot unit 0 has a peer interface of 1, and that is what you see. The peer unit is 1. Then, like any physical router, you assign a loopback interface. You give an IP address. I am also enabling protocol ospf on that physical interface unit, which is a part of R1. Similarly, for R2, I call the same LT00 parent interface, but in R2, unit 1 is a part of R2 interface. And same, you give encapsulation VLAN. You make sure that the VLAN IDs are matching because it's kind of like a one-to-one mapping. And the key here is here you call the peer unit. That is the most important thing. In R1, the peer unit is unit 1 because that's what is the peer unit. From R2 logical point of view, peer unit is 0. And you can see that's what I'm doing. And the IP addresses are pretty much like, they are connected back to back. They are part of the same subnet. And I've enabled ospf. Once you enable all this and commit it, now if you check show ospf neighbors, it is not going to show you that because you're running ospf neighbors on the physical router. Now to do or check anything specific to the logical router, you have to do show ospf neighbors logical system R1. So from R1 point of view, it is telling that it is formed an ospf neighborship towards this particular neighbor, which is 10.10.10.2. Likewise, if I check show ospf neighbors from logical system R2 point of view, you can very clearly say that it is formed a neighborship with 10.10.10.1. Likewise, you can create and build a pretty big topology that you want if you want to test in scenarios. I have used similar topologies in the past for creating my JNCIE lab or other labs. So you can see all this entire topology, which has got like almost like 8-10 routers, is all created using logical LT interfaces. So it's under one physical router. I have created so many routers. All you can see is using LT, LT3, LT1, 3, 10 in this case. In your case, whichever LT interface you are using, you can just use it. And you can see here dot 1 is talking to dot 2, dot 3 is talking to dot 4, and the circled numbers are the VLAN IDs that are specific to those interfaces. You can use this logic to create it. Up to 15 logical routers can be created on an MX. So from a physical box, you can create 15 logical routers. Most of the features would work. I would say 90% of features do work on logical system. Sometimes some features may not work, but that is something you can obviously find out when you test it. So as I was referencing in this topology, pretty much for my JNCIE lab in the past, I had used it and most of the features were working fine. So this is very helpful or handy when you're trying to validate some kind of quick protocol feature behavior, or you're trying to clarify your concepts. You can use this quickly without having to worry about connecting physical multiple routers. One more thing is if you want to specifically go into that individual logical router rather than running commands based on logical system, you can do set CLI logical system R1. So what this does is it takes you into the R1's point of view. So when you do show configuration, you only end up seeing R1's configuration. You will not see any other global configs or any other configs that is not relevant to R1. So it's more handy when you are running commands and checking things. Again, if you want to clear it, you do clear CLI logical systems. Now if I want to go back to R2, same command, set CLI logical system R2, and if you do show ospf neighbors, you can see that it is saying that it's forming neighborship and working fine. So I'm just going to clear logical system again. So you're going back to the main system. If you don't want to use this set CLI and you want to map it for each logical router, let's say I create a logical username password and you can map it out. So let me show you what I refer to that. So show configuration system login user R1. So what I've done is I've created a user called R1 and I've assigned a class called R1 here. So what does this class have? This is configuration system login class R1. You see, class R1 is got permissions to only access logical system R1. So when you connect to the main router using your username as R1 and whatever is your password, because this username R1 is associated with class R1 who has got permissions only to logical system R1. So when you use that username and login, you straight away log in only to the R1 prompt. It's like you will be like this. You'll be here showing up just R1. So it gives you a feel that as though you are logging into each individual router, even though under the hood it is a logical system. So it's quite handy to use and test, any kind of protocol concepts that you want to clarify or quickly check certain behaviors. It's a very handy way of doing it. Hope you find this useful. Bye for now.